Okay, make r the subject of the formula a equals pi r squared, where r is positive. Okay, so a equals pi r squared. So the first thing we want to do is get rid of the pi, divide both sides by pi a over pi, because this squared is only applying to the r, and then square root both sides, a over pi. We're just interested in the positive square root because r is positive, so the square root of a over pi, making sure it's clear that the square root is over all of it. Okay, then the area of the circle is 14, corrected two significant figures. Work out the lower bound for the radius of the circle. I've done all the figures on your calculator display. So a equals 14 to two significant figures. So that means those two values, which means the next one we're not sure about. Okay, and if we want the lower value, what's the lowest it could be? The lower bound is going to be 13.5, because that would still round to 14 to two significant figures. Anything lower than that, 13.4, that would round to 13, so it wouldn't be there. So that's the lowest it can be. And we want the lower bound for the radius, so we know what the radius is because we've just done that, is a 13.5 divided by pi. And it tells me to write down all the numbers on my calculator, so I will do as it says. 13.5 divided by pi, 2.072964897. There we go. Okay, give the radius of the circle to an appropriate degree of accuracy. You must show your working and explain how you obtained your answer. Well, we've got a lower bound. The key is actually working out an upper bound. So the upper bound, well, by the same thing that we've done before, is we're going to go to the highest it could possibly be. Well, 14.5 is the bound. It's actually got to be just slightly less than 14.5, but we call 14.5 the bound, divided by pi. Okay, so 14.499999, which is effectively 14.5. So we're going to use that, so let's just change this to 14. There we go, and we've got 2.148369928. So it then says, work an appropriate degree of accuracy. Well, if we said that it was 2.07, well, it might not be, okay, because it looks like it's 2.14. So we've got to have an appropriate degree of accuracy that is, if we round both these numbers, they come to the same thing. So if we round both of these to two decimal places, then they're different. But if we round it to one decimal place, this is 2.1 and this is 2.1. So our answer is 2.1 to one decimal place, or two significant figures. Okay.